Hi everyone, I am Manish speaking. Today the topic is importance of hydrology in civil engineering, and I will be saying importance of hydrologies, and the contents are introductions of hydrology, history of engineering hydrology, importance of civil engineering hydrology, applications of hydrology, scope of hydrology in civil engineering, hydrological cycle, components of hydrological cycle, and its conclusions. These are the contents and the topics I am today speaking about in this topic. Introduction. Hydrology in civil engineering may be understood as the branch of the civil engineering that deals with the study of the water resources. It is also commonly referred as the water resources. Precisely, engineering hydrology may be defined as the multidisciplinary specialization of the civil engineering that deals with the occurrence, circulation, and distribution of water on the earth. Mostly engineering hydrology is focused on the scientific study of the water cycle, water resources, and water resources sustainability. It mainly focuses on the planning, design, analysis, and operation of water-related projects and construction by utilization and efficient management of the water resources. These are the introduction of hydrology and the water cycle shown in the picture. The water cycle contains condensation, precipitation, surface runoff, evaporation, infiltration, groundwater, and surface water. This is a cycle flow chart. Cycle for the water cycle. Water cycle. Mm. History of engineering hydrology. Engineering hydrology has been an important study of the very long time. Ever since the dawn of civilization, various hydraulic structures have been constructed by the use of hydrological tools. From the example, during the Mesopotamian civilization, dams were constructed for protecting the Mesopotamian towns from floods. Numerous aqueducts were built by the Greek and Romans. Irrigation activities were evident since the history of the Chinese development. The development of advancement of engineering hydrology began in the 1st century BC. These are the history of engineering hydrology. Importance of hydrology in civil engineering. Engineering hydrology and its applications are inevitable for the planning, building hydraulic structures. It is important for the solving the various existing water related problems such as problems regarding the quantity of water control, mitigation, and floods irrigation, etc. Some of the importance of engineering hydrology can be listed as follows. It is necessary for determining the maximum probable floods at the proposed construction site, for the example dam construction. Its facilities engineers and hydrologistic for the establishing the relation between surface water of catchment and underground water resources. It is unable to one determine the flow of over various hydraulic structures and such surface between water catchment and underground water resources. It is unable to determine the flow of various hydraulic structures such as spillways, highway culverts, urban storm drainage system, etc. It is important for the studying the one-side drainage and seepage condition before the commencement of any engineer construction. The nature of the variation of water flow, rainfall pattern, etc. be obtained by the engineering hydrology application. It is necessary for determining the receiver's capacity to assure and advocate supply of the water for the domestic and other purpose. Application of area hydrology in civil engineering. The main application area is in the field civil engineering can be listed as follows: irrigation projects, schemes, hydroelectric power generation, power projects and dam construction, water supply projects, disaster prevention or flood control projects, and figure is shown in the page. These are the applications of hydrology in civil engineering. Scope of hydrology in civil engineering. The main scope of engineering hydrology is briefly described as follows: determination of maximum probable flood, determination of minimum intensity of storm, determination of water yield basin, groundwater development study. The maximum probable flood at the proposed site can be determined by the techniques of engineering hydrology. It is necessary to determine the frequency and occurrence of floods for designing and building hydraulic structures such as dam, flood control structures and receivers. Determination of maximum intensity of storm. The determination of maximum intensity of stone is necessary to determine the drainage condition at the site and design drainage system. Determination of water yield of basin. For the design of construction of various structures such as municipal water tanks, receivers, inland in navigation, etc., it is necessary to determine the yield of the basin. The occurrence, frequency, and quantity of water can be obtained by the basin. Groundwater development, engineering hydrology facility, the study of the groundwater, its development and its development. Hydrological cycle, and the figure is shown in the picture. The hydrological cycle is commonly referred as water cycle. The hydrological cycle may be defined as the process in which water from all the freshwater source, ocean and land move to the atmosphere and back in the form of the precipitation. It is inevitable for the balance in the ecosystem and biological system of the earth. It is inevitably necessary for the cycling and process of solar energy, sediments and other elements that are necessary for sustainable life of earth. The hydrological cycle consists of series of processes such as evaporation, precipitation, percolation, runoff, etc. It is a continuous cycle. This cycle is a continuous cycle. Groundwater, stream, river, ocean. Some parts are mentioned, and this by seeing the picture we can understand the cycle of the hydrological cycle. These are the points of the hydrological cycle. Components of hydrological cycle. The main components of the hydrological cycle can be listed as follows: as precipitation, evaporation, transpiration, evapotranspiration. Precipitation, it is referred as forms of water that all fall from atmosphere to the surface of, such as rain, drizzle, snow, etc. Evaporation, it refers the physical process in which water from the land and water from the surface of the earth is converted as vapor form. Transpiration, it is referred as process in which water from the soil absorbed by the plant's roots and discharged backwater atmosphere through the leaves to the little pores present in the leaves where known as stomata. Evapotranspiration, it is combined process of evaporation, transpiration and involves transport to the water to the atmosphere, both from water source to vegetation. And there are some points to the this: infiltration, percolation, overland flow, surface runoff. Infiltration, it refers the movement of water and ground surface to the underlying soil layer. Percolation, it refers to the movement of subsurface water to the water table. Overland flow, it refers to runoff the flow through the surface of the ground, a stream, a river channel. Surface runoff, it refers to all overland as the well precipitation and flow to the stream and river channel. At the end, we will know the conclusion. The engineering hydrology is mainly concerned with the following aspects: analysis, the estimation of water resources of the earth, both overground and underground; study and analysis of the hydrological cycle, components and integration among the components; the study of analysis, forecast and mitigation of water related disasters such as floods, droughts, etc. And this shows the hydrological cycle, and these are the topics which are we known about now. This will be the topic of hydrology in civil engineering, and thank you.